Glacier is still missing some of the industry structures, but I made some progress on the plastic container plant in the past couple of weeks. This plant is loosely based on the Amcor rigid plastics plant in Tumwater, Washington. I've put a Google Maps link in the description. The industry receives plastic pellets and covered hoppers and ships the finished product in trucks. Before I could start on the actual structure, I had to figure out where to put the fence around the property. The fence is an etched metal product that includes fence post detail and gates, so I had to work within these limitations to come up with a plan where exactly the fence line was supposed to go. Then I cut the fence sections to the required sizes and started soldering them together. I made sure to solder the sections as level as I could manage, because it is basically impossible to fix this type of misalignment after the fact. I also soldered 0.6mm steel wire to the fence in more or less regular intervals as my primary method of fixing the fence to the modulator. The steel wire also makes the fence more robust against accidental bumps during operating sessions. Soldering the fence sections is quite finicky, but I had good success by taping the sections to a piece of plywood and then soldering. Doing it this way makes it possible to get the alignment right and then solder in a separate step instead of having to do it all in one go. After test fitting and drilling holes for the steel wire mounting pins and the fence post detail, I spray painted the fence with Tamiya Gray primer from a rattle can, followed by a layer of sky gray and a little dusting of dark gray around the lower edge of the fence. Before I could install the fence, I had to prepare the asphalt lot. I had cut the required shape from a 0.75mm sheet of black styrene, which I sanded and glued to the module top. Previously, I have had good results with a solvent-based contact glue for this type of application, but this time I might have used too much of the glue, which resulted in the styrene to become increasingly deformed over the course of the following days. Luckily, most of this was limited to areas that were going to have buildings on top of them anyways. So I waited some more days to be sure that all of the solvent had evaporated and sanded the entire thing down to even out the ripples as much as I could. I wanted to have a concrete parking lot next to the asphalt right outside the fenced-in area. I used another sheet of styrene and scribed the lines representing the seams between the individual concrete slabs with the backside of a hobby knife. Having learned my lesson, I used odorless contact cement this time around. I had used this product before as well, so I knew I had to use a pretty liberal amount of the glue and apply pressure for a couple of days to make sure I won't have any issues with the corners or edges losing adhesion. When the glue had dried, I masked the styrene areas and applied a very small amount of plastic primer to the styrene. The primer is a type intended for PVC, so it's not styrene friendly at all, but can disturb the surface of the styrene just enough to give it a little bit of texture if used very carefully. After that, I could finally start painting the asphalt. I started with airbrushing a base coat of Tamiya XF24 dark gray. Then followed two relatively light sprays using XF53 neutral gray and XF19 sky gray respectively. Both times my goal was to have a good bit of the underlying color show through to give the asphalt lot more of the typical speckled mix of darker and lighter grays. To do so, I had to keep a fair distance between the airbrush and the styrene sheet and almost let the colors rain down instead of actively spraying them. To finish the asphalt base, I sprayed a thin trim of XF78 wooden deck 10 around the edges to simulate accumulated dirt. The parking lot received a base coat of Vallejo concrete, followed by a little bit of Tamiya XF19 sky gray and XF63 German gray. The key to painting asphalt and concrete lots is a little bit of variation in the colors. They should not look the same way over the entire area, but rather just same-y, because the different parts are subject to slightly different conditions and as a result weather slightly different from each other. The main building was constructed with wall parts from the Walthers Cornerstone Modern Concrete Warehouse Kit. After assembly, the walls received a coat of Vallejo primer, followed by a coat of Tamiya XF19 Sky Gray and a thin layer of XF57 Buff. This turned out way too dark and also too gray, so I followed up with a mix of XF2 Flat White, XF57 Buff and just a few drops of XF3 Flat Yellow. The roof of the structure was painted with Tamiya XF19 Sky Grey, followed by a misted-on layer of XF63 German Grey. The final touch was a very light mist of XF57 Buff. The prototype for this industry has a small metal annex attached to the main concrete structure, presumably housing some sort of technical equipment. In my version of the industry, I imagined it housing the pneumatic equipment for unloading the plastic pellets from the hoppers and for transporting the pellets into the silos. To add a little bit of interest, I wanted a small office for the supervisor as well. I cut the front and side walls from evergreen board and batten styrene sheets. Since I wanted to use right angle profiles as corner trim, I had to pay close attention to the exact locations for these cuts so I wouldn't end up with weird distances between the ribs and the trim. I had made a drawing with the general layout of the industry on my computer to nail down the footprint of the industry. This gave me the exact lengths for the walls, so it was easy to take the added width of the sidewalls into account for the trim. I was a bit too generous with the roof pitch, however, so the first version of the sidewalls resulted in a way too steep roof for my liking. Fortunately, this was easy enough to fix with another cut. In order to find the correct height for the door on the right side wall, I had to construct the adjacent concrete pad before continuing with the annex. I wanted the pad to be 4 scale feet high, which comes out as 7.5 mm in N scale. I chose to glue 3 layers of 2 mm thick styrene and 1 additional layer of 1.5 mm thick styrene to get to the required height. I had chosen the height for the pad to match the height of the stairs from the Walthers kit. After the layers for the pad were glued, the pad was just a tiny bit higher than the stairs, so I sanded the pad down until it was a perfect match to the stairs. I used a piece of leftover plywood about an inch thick to act as a level surface while sanding, because I know that the desk I use as a workbench is not level at all. Since the pad layers were slightly different dimensions, I used strips cut from 0.5 mm thick styrene as trim, making sure to leave a gap in the trim for the stairs to fit in. Finally, I used Tamiya plastic putty to fill the remaining gaps, and after one last sanding pass, I had the concrete pad in hand to find the correct height for the access door to the annex. I propped up the side wall and the pad with 1, 2, 3 machinist blocks to find a location for the door that I liked, and then marked the location with a hobby knife and started to cut the door opening. As with all openings, I made the opening intentionally too small at first and continued to carefully make the opening bigger until I had a good fit. While I was working on the annex, I had also made some drawings for a couple of different vents and created additional openings for these 3D printed parts after I was done with the door. When all the openings were finished, I could finally start to glue the structure. I used my piece of plywood again to make sure I have a good surface to work on to get all the walls to properly square up. Then I added the corner trims. I had cut the right angle profiles a little bit too long, so I could trim and file them to follow the slope of the roof. This step is important to make sure that the roof sits flush on the sidewalls. After this, I slightly sanded the bottom of the structure to get rid of anything that might keep it from sitting properly on the module later. With the outer walls done, it was time to work on the interior of the structure. I wanted to add interior lighting to the office, but not the entire structure, so I had to install some interior walls and add an internal layer of black styrene to act as a light block. The opening for the window required some final touches with the hobby knife, and after cutting down the light block for the sidewall to follow the roof pitch, it was time to install the office floor. To ensure that I glue the floor reasonably level, I installed small styrene blocks for the floor to rest on. This way I could take my time to install them at the correct height individually. This left the roof as the last missing part of the structure. I cut the roof from the same board and batten styrene sheets I used for the sidewalls, cutting it slightly larger than the structure to achieve an overhang of about 2 mm. While cutting, I made sure that the cuts were right next to the batten part of the sheets so that there wouldn't be batten right next to the edges of the roof. Then I cut a piece of 2 mm right angle profile to represent the gutter and glued it in place using my steel ruler as a spacer. When the glue had dried, I carefully sanded the sides of the roof to make sure that the length of the gutter exactly matches the roof. While test fitting the roof, I noticed that it wasn't properly supported by the back wall of the annex, so I added a piece of styrene to give the roof a bit more rigidity. I used pieces of 0.5 mm right angle profiles for the trim of the side of the roof piece. I removed a bit of material from one leg to make the side trim fit the gutter and then glued the pieces into place. I paid special attention to the corner where the side trim and the gutter meet to make sure that they are properly bonded together. To represent the roof ventilation, I cut a 1.5 mm wide and 0.25 mm thick strip of styrene to the appropriate length and glued it into place. Thin styrene strips like this one bend easily, so I used a small steel ruler as a guide. After trimming the excess, it was time to start painting the parts. Small parts and even larger parts like the roof can be difficult to hold while painting, so I like to use double-sided sticky tape on a scrap piece of wood as a handle. After a primer layer using Tamiya Grey primer from a rattle can, I painted the roof with a mix of mostly a Tamiya XF2 flat white and a bit of XF19 Sky Grey from an airbrush. I used a mix of Tamiya flat white and XF57 buff with a little bit of XF53 neutral grey at first. The mix turned out to be a nice color by itself, but too close to the concrete color of the main structure, so I decided to do another pass. This time I used mostly sky grey, a little bit of white to get a lighter grey and a couple drops of buff to make the mix just a little bit warmer. All that remained then was to glue all the parts together and secure the annex to the module. This is the state that the module was in when traveling to the meetup in Rastede in April. I hope you found this video interesting. See you next time.